Okay, let me just show you some examples of using this STEPFPGA board to implement some cool Verilog projects. Well, for demonstration purpose, I'm going to use this bigger version of the STEPFPGA board. This is called Step Plus. This is pretty much exactly the same functionality with this small board, but multiply the dimension by 3. Yeah, let me just show the example on my computer. Okay, let's get started. So first, go to our website, and you notice that in this tool section, we have a web IDE. Click on this. Okay, so now this page is purely a website-based IDE tool, allows you to do all the file management and project, all the stuff. So we click Start. Of course, I already pre-registered. So now you see the interface. We put a list of the project examples for people who are not familiar with this IDE, so you can get started very quickly. For example, we have like 4 adders, blinking LED, 3x8 decoder, segment display, whatever. But now let's just show example how to create a project from start. So to start, I just name a project, for example, Decoder 3.8, and select the board. The board we have is MX02 core board. So select this one and submit. Okay, we got success. And click this one to create a new file. So currently our platform only supports Verilog, so bear with me. So usually you can name whatever you want, but for a good habit, I would just say keep the same as such. So Decoder 3.8, submit. Okay, so of course I just copy paste the Decoder 3x8 code somewhere from this project to save some time. Essentially, I have instantiate 2x4 decoder modules here and do some wirings internally, so that whenever you have 3 inputs, and it gives you the 8 distinctive output. This is essentially what 3x8 decoder does. Click Save and do the logic synthesis. So this step allows you to convert your Verilog code to the equivalent logic gates. We got success here. By the way, all these project examples have been pre-tested, so you have to you don't have to worry about the bug issues, whatever. So next step is pin assignment. Well, this is the amazing part, because traditionally you're gonna have to, find a table corresponding to all the FPGA pin mappings, and you do that one by one. But for here, we use a graphical way, so that when you do the pin assignment, it's gonna be really easy and won't make any mistake. For example, for the 3x8 decoder, we have 3 inputs and 8 outputs. The 3 inputs, we can just assign that to the 3 switches here, toggle switches. So let's go to the switches section. So switch, we're gonna use the 3 toggle switches for the input, and the 8 output we can assign that to the 8 LEDs. Okay, so the D0, D1, D2, to all of them. Just bear with me. Okay. So you notice that whenever I have assigned all those pins, you see all those components have been highlighted with the orange color. So you know that these pins have been fully assigned. And now we click Save. I got success. That's good. Then we can do the continue for the FPGA mapping. So the FPGA mapping just converts everything you have done before to actual implementation file, which we call it JED file here. So basically like compiling everything into executable machine codes, right? So we got success here. So we download that into the board. Well, we have 2 options. The first one, if you just download that, just download your project, including the source code and the implementation file, into your own computer or whatever you want to save them. The other option is you just directly burn that into your board. It's the JED file, implementation JED. So as I just showed you guys a moment ago, when you plug in the FPGA, you have external, the step link. The FPGA board has been hardware configured as a USB flash drive, which is very convenient for you to download and program the board. So we have this flash drive. So all you need is just download this and save that to the location where this flash drive is located. So just save that to this USB flash drive. Okay, it takes about 5 or 6 seconds, so it automatically finished. Okay, you see it's finished. So now I will just show you how it's being acted on this board. Okay, I have uploaded this board with the program we just written, and as I previously mentioned, I'm going to use this Step Plus for better illustration and demonstration purpose. Now we have a 3x8 decoder. As we just noticed, the 3 inputs of the module has been assigned to the 3 toggle switches on this board, right? And the 8 output pins are assigned to the 8 LEDs. So if we just switch the inputs, you will notice the output changes correspondingly. And if you just recall from the truth table and check against with the effects here, you will notice that these two have the same effects. But just be aware that our FPGA has been configured as such that all the LEDs are inverted logic. So meaning if this one is turning off, that is actually representing a logic 1. Yeah, just be aware of that. Otherwise, you will notice that all of the effects or logic behavior exactly match what you are expecting for a 3x8 decoder. Okay, yeah, that's done for this example, and let me just show you another one.